Okay, without further ado, welcome everybody, and thank you for joining this session of TDengine IDMP webinar. Today specifically, we're going to be going over the microgrid with Sparkplug B scenario that you can find on our website. I'll attach a link somewhere on the chat so you guys can check it out. But let's go ahead and give it a shot. Before we start, again, this is the demo that we're doing. Let's give you a little bit of an introduction on exactly what's happening here. So if we go over and look at the environment setup on the website, this link will be posted in the chat. Basically, we're taking a MQTT broker, and what MQTT is, it's a lightweight protocol that publishes data, and it's perfect for IoT and industrial devices. And this scenario is actually based on a client scenario. So you'll find this situation kind of similar to what happens in the real world, but here's how it kind of works. So there's a device that acts as a MQTT client, and it publishes a message to our broker. And in this demo, it's an Eclipse Mosquito broker. Other clients can subscribe to different topics and stuff like that. But what is Sparkplug B? As you can see here, Sparkplug B is a standardization for the data. So it's an industrial data model that's on top of the MQTT broker that collects data into standardized topics and payloads. You'll see kind of how our data is done here when we actually dive into it. But payloads like metric names, types, engineering units, timescapes, and all of that can be done. So in short, MQTT handles the transport of data, Sparkplug B handles the kind of semantics, and together they create that like plug and play layer for industrial data. So where does TDengine kind of slot into here? Well, TDengine subscribes to that MQTT broker. It automatically parses the Sparkplug B payloads, and then those readings are then written into the TSDB. So it's a no code, no middleware, and no ETL, zero code ingestion pipeline. All you have to do is set up the kind of architecture, which is listed here. And so what do I need to set this up? You need a Sparkplug B simulator on your machine. If you're using a Mac, you're probably 2020 and onwards are going to want to download the ARM64 system one, and everyone else is going to download the x64 systems one. That's pretty much it as far to Sparkplug B. For Docker, you're going to want to install Docker Engine and Docker Compose. One caveat, though, is that if you are on PC or Mac, it might just be easier for you to install Docker Desktop because it is a GUI interface. It's much easier for you to kind of get up and set and going. So again, the TSDB is the database engine that we have, and the IDMP is the visualization platform. And the containers we're going to be using today is the TSDB, the IDMP, and then the MQTT. And you should see all of those in your Docker instance. You're also going to want to have Git installed. There's a pretty simple guide on how to do it on the Git website. But once you have all of those installed, you can kind of get to setting up. So first, you're going to clone your Git repository, obviously, and you should see it cloned. So just simply run this command, and then you're going to go into the Docker folder inside the file structure of the Git repository, and then you're going to run Docker Compose upd, right? And this will automatically pull the required images from IDMP and TSDB, and then start it in detached mode. So you're going to be fully running everything on your Docker instance. Once you do that, you're going to add the MQTT broker. So again, to caveat, you're going to have to install the Spark B simulator before all of this. But once you run the EV MQTT broker, you should see it. So here in my Docker instance, I could see my MQTT broker that is running. Once you see it on your Docker desktop instance, or even when you could type in Docker PS to see it. It's another way to see it if you're not on a GUI platform. Once you see all three of those images are up and running and they're healthy, you can head over to TSDB at localhost 6060 or IDMP at 6042. Let's start at TSDB because that's where you're going to start doing your work. First, you're going to want to create a database. So how do I do that? Well, first you go into you're going to start at the dashboard, log in. The username's root and the password's house data. It's similar for everybody. sign in. It's very easy to get in. And you're going to usually start at the dashboard. That'll show you exactly what endpoints you're on, how much CPU usage you have, what the memory usage is, and your service status. Everything should be green and you should be good to go. You should go to the Explorer. And when you go to the Explorer, just go ahead and click Create Database. Here, you just name it Database Microgrid. I've already done that. But once you go through, that's pretty much all you need to touch. The crux and the most important thing for this demo in particular is to actually generate the simulated data, right? And you can kind of see the scenario as described. We kind of have an industrial park that's got an inverter, it's got a battery, it's got an environmental sensor, and it's got a grid interface, and there's all these different metrics, and there's these different units that come with it. So first, you're going to want to copy that Sparkplug B simulator into your TSDB container. So into the root package, a root file of your TSDB container, you're going to copy that Sparkplug B simulator that you just downloaded. Now, this is probably the most important step and the one I think people will struggle with the most, and that's actually knowing what to change in this. So as you can see, this command says Arch, but obviously I have an ARM64 system, so I want to switch this to ARM64. It also will differ for the file extension. So it might just be .tar for you if you're using the ARM64 extension. But once you figure that out, go ahead and run that command. And then you're going to open the terminal. And then you're going to run this docker exec command. And that's going to put you inside the TSDB file path structure. Once again, run this. But obviously, you're going to put whichever system you're on. I'm on ARM64, so I'm going to put that. And then we're going to go into the SPDB pub file path. After that, you're going to download the simulator configuration file. So literally just copy and paste this. And then you're going to start the simulator. Once you start the simulator, you should see information like this. So something similar to this. And I think the best way to confirm that it's actually working is that it's going to say image successfully pulled. So subscribe success. And that's how you know that's actually worked, and you could continue to see it generate. So that's kind of how you know it's generated. It's a little high level and quick on how to do that, but if you've done everything right, you should see this successfully connected. Again, some of the common steps that you could miss is not switching this Arch. This is different for everybody. You have to replace with x64 if you're on Windows, and this depends on your processor. So again, you could have an older Mac, so you might have to do x64 anyway. But if you're on a newer Mac, ARM64 is the way to go. Once you're done with that, you should see this pop up. Great. Now, here's I guess the biggest part of this is the data ingestion task. So you're going to go to data in, and I've already created a data ingestion task called microgrid ingest. But if you want to view exactly how to create it, go ahead and go into here. You're going to click Sparkplug B, and you're going to select your target database. For me, it was DB Microgrid. And then now you're going to want to fill in this data, right? You could call it whatever you want. I could just call it Microgrid ingest webinar. Pretty simple to get that going. You enter the broker, which is the same for everyone, MQTT 1833, MQTT 1883. And then you're going to want to enable, you're going to want to keep alive. All these settings are left exactly the same. For the client ID, it could be whatever you want. I could do Aru, just something unique. Check connection. It should say your data source is reachable. That means that it's subscribed and it's completely running. Afterwards, you're going to want to go back into here, and there should be a set of things that you want to subscribe to. For this scenario, we're going to go with the industrial park. So simply just copy and paste the group ID, industrial park. The node device lists, again, go through this, copy and paste. Really simple to get going. Node device lists, ready to go. And then you're going to also want to copy and paste dbirth and ddata. That's the message type. And you're going to want to click, you're going to want to enable rebirth CMD. And once you see that everything looks like this, you can just go ahead and do retrieve from server. And this will automatically show you exactly what's parsed from this data. and then you're going to want to go in and edit your super table. So it's pretty fast and simple to get this process up and running. The difficult part is actually configuring the super table, but the demo makes it really elegant to do. All you really need to do is adjust some of the pre-configured things. Right here, you could see that it's brought in a ton of columns. Don't be intimidated. You could just easily get rid of all of them except for the timestamp column, which you can't get rid of. You're just going to keep going through these until you've reached just the timestamp column. You're going to name it timestamp, and you can name it whatever you want. Here, I'm just going to name it TSDB microgrid to follow the demo. Timestamp, and we're going to add another column, right? And the second column is going to be double. And here you should just name it value. And then you have 3 more, right? So we're going to have a group ID, an edge node ID, and a device ID. Right now, we're just defining that super table. And once you're done with that, it should automatically populate. So all 3 of these, 3 varchars. And again, I can go through this, but once you're done with this step, you should automatically start to see it recognize all this data. So here, I'm just going to go through this really quick to speed up this process for you guys. And I believe the first one is group ID, edge device ID, and device ID. Once your super table is defined, mine already exists, so I can't create this one, but I can name it something else probably. And create, just to show you guys a different super table. All of it should already be pretty much mapped. If it's not, you can adjust the ones that aren't mapped. And for timestamp, you're just going to turn it into a generator. And for the table name, we already have a table name for you guys. Just go ahead and copy and paste this. Once all of that is done, there shouldn't really be any errors, and you should see all these blue check marks. You're good to go on ingesting data. So I could hit submit here, run. I've already done it, so I don't want to go through that process with you guys. It'll mess up the data I already have. But that should be it. Once that's done, you should see it running here after a second in your data in task. And here mine's called Microgrid Ingest. Once that's done, you can go back to the data explorer that we just came from. So for me, it was DB Microgrid. And you can actually check here. So I made this table. I can delete it. I'm going to go ahead and get rid of that one. But this is what you want to see. And you can go through and make sure all the rows have been exported. Looks good to me. Make sure all that data is coming in and flowing nicely. And it looks like it is. So we should be good to go. Cool. So everything looks good. Now you're going to want to go back. If you're lost here, typically some of the things that I've seen go wrong is that you haven't actually started it from the root of the TSDB. So it doesn't know where to get the data from. That's something you have to check. Make sure you know the configuration for what system you're on. If you're on Linux, leave the commands as normal. But for us PC and Mac users, you're going to have to change it up a little bit because we do have GUI interfaces. So that's another thing. And make sure that the metrics actually populate correctly. When you look at it through this, you're going to want to make sure that it looks like our demo. And it's a pretty easy way to confirm that this is working. Cool. Mine looks about right. So I'm going to get started with the next step, which is the visualization. And that's going to be in TDengine's IDMP, right? So going into IDMP, you'll start by seeing this screen right here. I've already defined mine called Microgrid, but I'm just going to go through it with you guys just so you have a good look at it. You can configure element templates pretty easily. So if you go to event libraries and you'll see element template, I've already made this one here, but PV inverter, give it a naming pattern. You're going to want to go through and do it for every single element. So there's grid interface, there's battery one, there's an environmental sensor. Just go through, create one for each one. You can also create an attribute template, right? So if I add that PV inverter here, so add new child element, reference type strong, If I go to the template, I should see PV inverter confirm. Hold on, give me a sec. Yep, so that's already up for me. That's why it's not popping up. I can go into attributes, and then I could create a new attribute. So again, go to libraries, general, attribute template, create a new attribute template. Go ahead and enter solar PV output. You could set the OEM class, change the display UEM, select the power, and then change the reference type to TDengine metric. Once you click inside the data reference exception, you can select TDengine, and then you'll see your database actually pop up. So the whole table pattern, PV inverter, solar PV output, and the value will all pop up. It's pretty simple to get going. And then once you've clicked configure, you can go ahead and add it to your asset model. So under elements, right over here, and again, TDengine uses a tree structure. It should be pretty familiar if you're used to IoT systems. You can go ahead and create something like this, where you have a microgrid and you have child elements, and you can name it some other things. So I've named mine microgrid, but again, I can show you how easy it is to change. And change this to industrial park. Click save, and you're ready to go. So you can create a reference to different elements. So obviously the PV inverter is one of them, and you could have one PV inverter each. And you could see the attributes of each of those. So if I go into an individual, I can check its attributes, and you can see exactly what we saw in TSDB. So that should pop up for you. Cool. So once that's done, let's see exactly how we can use this data, right? So you want to use this data in unique ways, and I've already configured some data for you to kind of see how that works. But here's kind of the magic of it all. With most IoT systems, you're going to need some kind of source expert to get data like this into tables. So before all of this starts, you're going to want to make sure that an AI connection is actually configured, right? So right now AI is generating my insights, but if you're having issues with that, make sure you go to your connections page and see that some type of AI connection is being used. Here I'm using OpenAI. You guys can use whatever model you want. There's just a couple different steps, but pretty much what you need is an endpoint and a connection. And once you see that and it says in use, you're ready to go. So right here, I could see that there is 3 distinct ways to make panels, right? So first way is through suggestions. So my LLM has already aggregated all of that data that we just fed it through TSDB. And then taking that data, it's created intelligent insights, right? So something that I want to know. So a proportion value of microgrid devices below 20 in the past day, a ranking of SCB micro devices for the past week, average hourly value for the past day. So it's a suggestion-based system, so I can like or dislike, and it'll show me different ones. We're going to do the past day instead. Show you guys that real-time generation. And it's just taking a little bit to load, but this is what it should look like. Once you're satisfied with your result, you can click save, go back, and you can actually see the template pop up. That's one way to make something. You can also just intelligently prompt them. So if I want to know the distribution of devices for the past day in a gauge chart, I could do that, right? I don't really need to know much about this data to create these. It's pretty easy to just spin up. And what can I do once I've actually made this? Well, you could also turn off the AI suggestions too, right? So if I didn't want anything to do with AI, I could just make the panels myself. I go to child elements, go into this, throw this value in, add to metrics, good to go. So 3 different ways to kind of make panels. But what can I do once these panels are done? Well, it's really easy to also spin up a dashboard. So here I've already made one. You're pretty much able to add panels. straight to this and see the data pop up. So I can drag and drop panels right here. Maybe it's because I'm on this panel. So I'm actually going to go back to the Explorer, switch to a dashboard. Okay, so yeah, I can drag and drop panels with the data popping up. Very easy to kind of set this up and get going. But obviously dashboards and demos are nice, but something that you'd really want to configure is analyses. So if you give it a couple seconds here, AI will actually generate analyses for you. So if you think of an IoT-based system, you want these analyses to be very in-depth and kind of generated on the fly. Again, just like with the panels, analyses are generated based on the kind of metrics that you've given. So here I have 3 different ways of making them. One with the suggested analyses, one I can just create manually. I'm going to wait for some suggestions to pop up. So it says calculate the maximum value of the past 1 hour every 5 minutes. That might be important. So I'm going to create the analysis. Cool. So automatically that template's generated. It's tagged as AI generated. You can enable it upon creation. There is a max value already attached. This one's sliding, so because it's every 5 minutes for the past 1 hour, we're going to hit save. So we're going to hit save, and first it starts paused. You can just hit the refresh here, and it should be up and running. Boom. And you could see how simple it was to get that up and running. I could also prompt it if I wanted to. I could go into this and change it manually, like I said. So there's multiple ways to do it. And of course, you could always turn off the AI suggestions. But what can you actually do with these analyses? Well, you can use it to create events, right? So if I wanted to, I could generate an event template using that analysis. So if it goes over the max, email me. Once I hit confirm, that analogy, that template is already up. I can acknowledge it. I could send a notification to my email. I could get a trend chart of that. Right now it hasn't been an hour, so you can't see the actual trend chart. But if I go into my email, I should see it popping up in a minute there. And once again, you can acknowledge it. You can view exactly what's happening in this particular alert, the associated analysis, the associated element. I can favorite this. So when I go through favorite elements and element filters, I can see that. So just another easy way to use AI to help you in your day-to-day tasks. Another thing that you could do is use our AI chat. So over here, you can ask it questions about your data, right? So tell me about, looking here, tell me about battery 1. So we'll be thinking for a couple seconds here. Okay. Tell me about the battery 1. So here it shows me the charge rated battery 1, and it generates a graph for me. You can download this graph. You can save it as an image. You can view the data, and it's really simple here. I even messed up the spelling, and I can see it. So it offers pretty intelligent insights on different things you could do with this. I could take these insights and create a trend chart if I wanted to. I could switch it. I could switch it to a bar chart, switch it to a stack, and I can also ask it general questions on each of the elements itself. So that's another cool AI feature. Combining all these features together, you get a really powerful system on intelligent analysis and attributes that you can analyze, and it's truly the easiest way to ingest this kind of MQTT data and IoT data in general.